It begins the way most discoveries do, quietly. A single dot of light, barely brighter than the background stars, so faint that, at first, no one pays much attention. Every night, telescopes sweep the sky. They catalogue rocks, dust, and ice without emotion. Most objects are familiar, predictable, forgettable. And this one, at first, is no different. It appears along the ecliptic, the invisible highway where planets move. A routine detection, a routine entry in a database filled with millions just like it. Another cold traveler, another name waiting to be assigned. But then, someone notices something small, not dramatic, not alarming, just wrong. The object's motion doesn't quite match the sun's pull. Its speed is unusual, too fast to belong here. At first, it's blamed on error, a calibration issue. A tired researcher double-checks the math, then checks again and again. The numbers don't change. The object isn't slowing down the way it should. It's not falling inward like a comet born around our sun. It's passing through. That's when the word appears on the screen, a word no one uses lightly. Interstellar. Not from here, not formed with the planets, not shaped by the same early chaos that made Earth, Mars, or Jupiter. This thing comes from somewhere else. The room goes quiet because interstellar objects are rare, extremely rare. Before this century, humanity had never confirmed even one. Then one arrived, then another. And now this, catalogued as 3I/Atlas, a name that sounds technical, cold, safe, but behind the label is a truth that feels heavier. This object has traveled for millions, maybe billions of years, through empty space. It has passed stars that burned out before Earth even existed. It has crossed darkness so deep that light itself struggles to survive. And now, by chance or fate, it has entered our sky. Scientists track its path backward. They rewind its journey across the galaxy. They follow the line through space and time, and the conclusion becomes impossible to ignore. 3I/Atlas was never bound to our sun. It wasn't captured. It wasn't thrown outward. It arrived with speed, with intent, with momentum that suggests it has always been moving forward, like it was never meant to stop. At first, the excitement is quiet and professional. Emails are sent. Observatories are notified. Just another discovery, on paper. But inside, something shifts. Because when something comes from beyond our system, it brings history we cannot read. We don't know the star it came from. We don't know the conditions that shaped it. We don't know what forces touched it, or changed it, or stripped it down. Every interstellar visitor is a message written in a language we barely understand. And this one feels different. As the days pass, more telescopes turn toward it. Infrared, optical, radio. The object doesn't glow like most comets. It doesn't trail gas the same way. It doesn't behave badly enough to be exciting, yet not normally enough to be ignored. It sits in an uncomfortable space between categories. Too clean, too steady. Someone describes it as quiet, not silent, just reserved, as if it's holding something back. As 3I/Atlas approaches the inner system, the sun begins to touch it. Light brushes its surface, and still nothing dramatic happens. No explosive outgassing, no violent tail, just a calm response to a star that should be waking it up. That calm is unsettling, Because space is harsh. Radiation scars surfaces. Heat cracks ice. Time destroys structure. Most objects show it. This one doesn't. Its path continues to be refined. The math grows sharper. The margins shrink. And with each update, one truth becomes clearer. 3I/Atlas is not visiting us. It's passing through us, like a stranger who never planned to stop, never planned to look back. Late at night, researchers sit alone with the data. Not scared, not yet, just thoughtful. Because discovery is exciting, but it's also humbling. This object does not care that we see it. It does not slow down because we name it. It does not change because we are curious. It existed long before our questions, and it will continue long after them. And that realization settles in slowly. If something can cross the galaxy, enter our system, and leave untouched, what else might be out there doing the same? What else might have already passed by, unnoticed? 3I/Atlas doesn't announce itself. It doesn't shine brighter for attention. It doesn't send a signal. It simply moves, steady, precise, unbothered. And as scientists log the final confirmation of its interstellar origin, one quiet thought lingers in the background. If this object came from beyond our system, from a place we may never see, then it carries with it a story older than humanity, a story written in motion, material, and time. And this is only the moment we first noticed it. The discovery phase ends here. But the questions are just beginning, because once you realize something doesn't belong to your world, you can't stop wondering why it's here at all. At first, everything looks normal. The data arrives in neat rows and clean graphs. Brightness, distance, time, numbers doing exactly what numbers are supposed to do. Astronomers breathe easy, because when data behaves, it means the universe is still playing by the rules. 3I/Atlas reflects sunlight. Its brightness rises as it moves closer, falls as it turns away. Simple, predictable. A light curve that looks familiar, almost comforting. And for a brief moment, everyone relaxes. Because discovery is exciting, but normal is safe. Then the curve bends. Not sharply, not dramatically, just enough to notice. A slight rise where there should be a fall, a pause where there should be change. At first, it's ignored. Noise, they say. Background interference, cosmic dust, instrument drift. Space is messy. Data always needs cleaning. So they clean it. They filter out stars. They correct for angle. They adjust for distance. And when they're done, the bend is still there. The light curve refuses to straighten. Night after night, observatories across the planet watch the same object. Different telescopes, different skies, different teams. But the shape remains. The brightness of 3I/Atlas doesn't behave like ice. It doesn't behave like rock. It doesn't behave like dust. It behaves like something deciding when to shine. That's when the first quiet doubts appear. Comets are simple creatures. Dirty snowballs heated by the sun. As they warm, gas escapes. Dust spreads. Light scatters. The math is old. Tested. Reliable. Yet no model fits this curve. One researcher overlays known comet profiles. None align. Another tries asteroids. No match. They try tumbling objects. Binary bodies. Fragmenting cause. Still wrong. The curve bends, then straightens, then bends again. Like hesitation. Like adjustment. Like response. Someone jokes about it in a meeting. Maybe it's shy. The room laughs. Briefly, then the laughter fades, because jokes are often where discomfort hides. As more data pours in, the fracture deepens. The light curve shows small spikes, not random, not chaotic, timed, repeating, not perfectly, but close enough to feel intentional. Close enough to make people uncomfortable. They run simulations, thousands of them. If it's spinning fast, the curve should blur. If it's irregular, the brightness should flicker wildly. If it's venting gas, there should be signs, but there aren't. No tail surge, no plume, no dust cloud thick enough to explain the changes. Just a surface that brightens, dims, and brightens again, as if parts of it are turning on and off. Someone suggests unusual reflectivity, maybe metallic patches, maybe crystalline ice. It's a good idea. Until the math rejects it. Reflectivity alone can't explain the timing. The changes happen too evenly, too deliberately spaced. The phrase measurement anomaly starts appearing in reports. A safe phrase, a professional phrase. It means we don't know yet. But behind closed doors, another phrase whispers its way into conversation. Pattern. Patterns are dangerous. Because randomness is comforting, it means no one is in control. Patterns suggest order, and order suggests design. The light curve is plotted again, this time stretched across longer time frames. And something becomes impossible to ignore. The object brightens most when it shouldn't, when its angle to the sun is wrong, when the geometry says it should be dim. Yet there it is, brighter, as if it's choosing how to reflect light, not simply reacting to it. Emails fly between observatories, careful words, measured language. No one wants to be the first to say it out loud, because science rewards caution and punishes imagination. Still, the numbers keep speaking, and they don't care about reputations. They don't care about comfort. They only care about truth. A senior astronomer reruns the data from scratch. Raw inputs, no filters. The result is worse. Cleaner, but stranger. The curve is real. Not an artifact, not a glitch. Real behavior from a real object, doing something no natural model predicts. For the first time, someone writes a sentence and deletes it before sending. If this is an anomaly, delete. We may be misclassifying the object. Delete. Words matter. Because once you suggest an object isn't what we think it is, you open a door that doesn't close easily. The sun continues to pull 3IATLAS inward. Light grows stronger. Expectations rise. Most comets get louder near the sun. Brighter, messier. This one doesn't. It remains controlled. Its brightness shifts, but never explodes, like it's regulating itself. That thought stays unspoken, for now. The data is presented at a closed meeting. Graphs projected on a white wall, lines bending where they shouldn't. No one panics. No one gasps. Scientists rarely do. They just go quiet. Someone finally says it. I've never seen a light curve like this. No one disagrees. Another adds, and I've been doing this for 30 years. That's when the room changes, because experience matters. And when veterans are confused, it means something fundamental is being challenged. The question hangs in the air. Is this just an anomaly, or the first crack in our assumptions? Because assumptions are fragile. We assume comets are simple. We assume space is passive. We assume objects don't change unless forces act on them. But what if that assumption is wrong? What if something out there isn't just drifting, but responding? The meeting ends without conclusions. Only more observations scheduled, more data requested. Science moves forward, carefully, but privately, a new feeling settles in: unease. Because once numbers refuse to settle, neither do minds. And 3I/Atlas keeps moving. Silent, unexplained. Its light curve bending, quietly asking a question no one is ready to answer. What if this isn't noise? What if this is behavior? And if so, what does that say about everything we thought we knew? The numbers don't answer. They just keep bending. And somewhere between those curves, the mystery deepens. It starts with a blink, so small, so subtle, that at first no one trusts it. Just a slight rise in brightness, then a fall. Nothing dramatic, nothing loud, just a rhythm. At first it's dismissed. Space flickers all the time. Stars flare. Cosmic rays strike sensors. Instruments hiccup. A single blink means nothing. But then it happens again and again. Same rise, same fall, same spacing in time. That's when someone pauses the screen and leans closer. Because this isn't noise. Noise is messy. Noise doesn't keep time. This does. Across one observatory, the data shows it clearly. Brightness up, brightness down, like a slow heartbeat. They check the timestamps. Perfectly aligned. They check the calibration. Clean. They check the weather. Clear skies. Still, doubt remains. So they wait for confirmation. Hours later, a message arrives from another telescope on the other side of the planet. Same pattern, same timing, same pulse. Now it's uncomfortable, because coincidences don't cross continents. The brightness of 3I/Atlas isn't just changing, it's pulsing. Not wildly, not erratically, measured, controlled. As if something is turning, or opening, or responding. On purpose, someone suggests rotation. That's the obvious answer. Objects spin. Irregular shapes reflect light unevenly. But when they calculate the rotation speed, it doesn't fit. The pulse is too clean, too consistent. Most tumbling objects wobble. They stutter. This doesn't. The pulse doesn't drift. It doesn't decay. It keeps time, like it knows what time is. The interval is written down, then checked again, then checked by another team. The number doesn't change, not to the second. The brightness rises, holds, then fades, over and over. A pattern emerges, not just a pulse, but a sequence, a repeating cycle. And that's when the room goes quiet, because cycles mean structure. They overlay the pulse on previous data. It wasn't obvious before. It was hidden inside the noise. But now that they're looking for it, they see it everywhere. Jan Hallam observations. Old frames. Archived images. The pulse was always there. They just weren't expecting it. No comet has ever done this. Comets don't pulse. They explode. They vent. They shed material. They don't blink politely. Someone uses the word signal. Not officially, not in a paper, just casually, and immediately regrets it. Because signal carries weight. Signals imply intention, and intention implies a source, a mind, or at least a mechanism. Still, no one can unsee it now. The pulse lines up with no known physical process. Not solar wind, not magnetic fields, not shadowing from rotation. Every natural explanation falls short by just enough to matter. And the strangest part, the pulse doesn't get stronger near the sun. It doesn't weaken either. It stays steady, like it's independent of distance, independent of heat, independent of everything that should control it. That's when the question starts to form. Quietly, carefully. Why would a silent object emit a pulse, like a signal? No radio waves are detected, no audio frequencies, nothing we can hear. Just light, pure reflection. But reflection with rhythm, and rhythm is language's distant cousin. Not speech, but structure. Some suggest it's coincidence, layered on coincidence, a rare alignment of shape and spin. Possible, but unlikely. And science respects probability. When something is unlikely enough, it demands attention. The pulse continues, night after night, unaffected by observation, unaffected by scrutiny, as if it doesn't care that we've noticed. Or worse, as if it expected us to. A junior researcher plots the pulse against time, then against distance, then against orientation. Nothing breaks it. The interval holds. Someone finally asks the question everyone is avoiding. If this is a signal, who is it for? No one answers. Because that question opens a door science doesn't like to walk through. The safer option is machinery, automation. A natural process we haven't discovered yet. Something blind, unaware. But even machines are built for reasons. And this machine, if that's what it is doing just one thing, repeating. Not adjusting, not reacting, just pulsing. The idea surfaces slowly. Maybe it's not trying to talk. Maybe it's not broadcasting. Maybe the pulse isn't for us at all. Maybe it's internal, like a system check, like a heartbeat that doesn't care who hears it. That thought is somehow worse, because it suggests autonomy, something that exists for itself, not for discovery. As days pass, the pulse begins to feel familiar, predictable. And predictability breeds fear, because it replaces chaos with order. Order is harder to dismiss. The public doesn't know yet. Whiskers. This is still quiet science. Internal emails. Restricted meetings. But the people watching the data feel it. That creeping awareness. That subtle shift from curiosity to concern. Because once you accept that the pulse is real, you must ask what maintains it. Energy has to come from somewhere. Timing has to be regulated. Structure has to exist beneath the surface. And suddenly, 3I/Atlas feels less like a rock and more like a system. No one says artificial, not out loud, but the word starts to hover, unspoken, heavy. The pulse continues as the object moves closer to perihelion, closer to our star, closer to scrutiny. Yet it doesn't change its rhythm, as if the sun is irrelevant, as if the pulse obeys rules older than our system, older than our light. Late one night, someone watches the live feed alone. The pulse rises, falls, rises again. And for the first time, it feels personal. Not because it's speaking, but because it isn't. Because whatever is doing this is doing it without acknowledging us at all. That realization lands quietly and stays. If this is a signal, it isn't a greeting. If it's a message, it isn't meant for human ears. And if it's neither, then it's something far stranger. A behavior without audience, a rhythm without witness, a pulse where none should exist. The chapter ends without answers, only a steady beat, moving through space, unconcerned with who is watching. And the question lingers long after the screen goes dark. If this isn't randomness, then what is it counting? And more importantly, what happens when the pulse stops? It begins with a glare, not constant, not blinding, just a sudden flash, as if something briefly catches the sun and throws it back into space. At first, it looks like ice. That's the safe answer. Comets are full of ice, dirty ice, ancient ice. When sunlight hits them just right, they shine. So the brightness spike is logged and explained and almost forgotten. Almost, then it happens again. Same intensity, same sharpness, but from a different angle. That's when someone slows the rotation model, frame by frame. As 3I/Atlas turns, its surface doesn't glow evenly. It doesn't soften. It doesn't fade. It flashes. Bright, then dull, then bright again. Like a mirror rotating in the dark. Except, no known comet surface behaves like a mirror. Ice scatters light. Rock absorbs it. This does both. The reflectivity jumps from brighter than clean ice to darker than charcoal in moments. Too fast, too extreme. The surface isn't uniform, it's segmented. And that's unsettling, because nature prefers gradients, smooth transitions, messy edges. This object doesn't. Its reflectivity changes abruptly, like panels turning toward the sun, then away. Someone zooms in on the brightness curve. The flashes line up with the pulse from earlier data. Not perfectly, but close. Close enough to suggest connection. That's when the room starts to feel tight. Reflectivity isn't just about material. It's about texture, orientation, structure. And structure implies design. They test the obvious ideas first. Crystalline ice, metal-rich rock, exotic minerals. Each theory holds until it doesn't. Metal should heat fast, but thermal data says no. Ice should sublimate, but there's no plume. Rock should be steady, but the brightness jumps. The surface seems to choose when to shine and when not to. As if reflectivity is being managed, not inherited. One scientist compares it to solar panels, then laughs. Too far, they say. Too imaginative. But no one laughs back, because the analogy fits a little too well. Flat regions. Sharp brightness changes. Angle-dependent reflection. The sun hits it, and something answers. Not passively, selectively. Another team runs polarization tests. Light reflected from natural surfaces has a signature, a fingerprint. This one is strange. Part of the light behaves normally. Part of it doesn't, as if two different surfaces are responding at once. Or one surface with layered properties. The phrase unnatural reflectivity appears in a draft report, then gets softened. Unusual, unexpected. Words are adjusted to sound safer, but the meaning doesn't change. This thing does not reflect light like a comet. As 3I/Atlas continues to rotate, the flashes remain consistent. They don't degrade. They don't erode. Radiation should roughen surfaces over time. Micrometeoroids should scar it. But the reflectivity remains clean, precise, preserved. As if the surface is protected, or renewed, or simply not vulnerable the way natural objects are. That thought lingers. Protection implies purpose, and purpose implies intent. Still, no one says it. Instead, they keep measuring, comparing, arguing quietly over late-night calls. Some suggest it's a trick of geometry, a rare alignment of facets. Possible, but unlikely. The probability gets smaller with every flash. What's worse, the flashes don't weaken as the object nears perihelion. Sunlight grows harsher, radiation increases. Most surfaces bleach or burn. This one doesn't. It answers the sun the same way every time, like it's built for this. That realization lands slowly. Because if a surface can manage light, it can manage heat. And if it can manage heat, then earlier thermal anomalies start to make sense. Pieces begin to connect, not cleanly, not comfortably, but convincingly. Someone pulls up a comparison image, a known comet, then 3I/Atlas, side by side. One looks chaotic, rough, alive in its mess. The other looks quiet, too controlled. A senior researcher stares at the screen longer than usual, then says something simple. "I don't know what this is." That sentence carries weight. Because science is built on knowing, or at least knowing what you don't know. This feels different. This feels like staring at a tool without understanding its function. The sun keeps shining. 3I/Atlas keeps turning. Flash, dull. Flash, like an eye blinking. Like a signal reflecting itself. The public still doesn't know, but inside the data rooms, a shift is happening. From curiosity to caution. Because reflectivity is not random. It's a choice made by material, and material is shaped by environment, or by intention. And this environment, interstellar space, is brutal. Nothing stays polished out there by accident. As the object moves deeper into our system, one last test is run. They model what would happen if the surface were engineered. Layered. Directional. Purpose-built. The simulation matches the data. Better than anything else so far. The result isn't announced. It's just noticed, saved, filed away. Because once you accept that possibility, you can't unknow it. The flashes continue, unbothered by our theories, unaffected by our doubt. 3I/Atlas doesn't explain itself. It doesn't slow down. It doesn't hide. It simply keeps turning, catching the sun, and answering back in a way nothing else ever has. And the question grows heavier. What kind of material does this? What kind of object needs to decide how it reflects a star? And if the surface is built to manage light, then what else is hidden beneath it? At first, the heat makes sense. Everything near the sun heats up. That's the rule. Ice melts. Rock warms. Dust glows. It's simple, reliable. Distance equals temperature. So when thermal sensors lock onto 3I/Atlas, No one expects surprises. They expect a smooth curve, a slow rise as it approaches perihelion, a slow fall as it moves away. That's how space works. Until it doesn't. The first thermal reading looks fine. Warmth increasing, just as predicted. Then the next reading arrives. And the temperature drops. Not slightly. Not within error. It drops sharply. Someone refreshes the screen. Checks the units. Checks the calibration. Maybe the sensor glitched. Maybe cosmic radiation interfered. They flag it and move on. But an hour later, the temperature rises again, higher than before. Then later, it cools, then warms, like a breath. In, out, in, out. The sun hasn't changed, the distance hasn't changed, but the heat has. That's when the discomfort begins. Thermal behavior is not optional. Objects don't choose when to heat or cool. They respond automatically, blindly. Yet 3I/Atlas isn't following that script. The thermal curve doesn't match perihelion distance. It doesn't match rotation. It doesn't match reflectivity alone. It breaks the rule everyone learns first. Closer should mean hotter. Farther should mean colder. But this object cools when it should heat, and heats when it should cool, as if something inside is managing the flow. The data is sent to another lab. Independent verification. Same result. Another thermal sensor confirms it. Different wavelength. Same behavior. Now the word anomaly is no longer enough. This is a pattern, a thermal pattern, and it doesn't behave like nature. Someone suggests shadowing. Maybe parts of the object shield others. That can cause variation, but not this much. Not this clean. Not this timed. The cooling happens abruptly, then stops. The warming starts suddenly, then stabilizes. No gradual transition, no natural lag. Just control. And control is a dangerous word. Because control implies feedback. Feedback implies sensing. Sensing implies awareness, or at least response. They try one last safe explanation. Outgassing. When gas escapes, it cools the surface. Comets do that. But outgassing leaves signatures, jets, plumes, tails. There are none. No visible release. No dust cloud. No chemical traces. It cools without venting. That shouldn't be possible. A junior analyst compares the thermal curve to engineered systems. Heat shields, insulated hulls, layered materials. The resemblance is uncomfortable. Some materials can reflect heat inward or outward. Some can store energy, then release it later. But those materials are designed, built, not found, drifting between stars. Someone finally asks the question no one wants to answer. If it's not alive, how does it regulate itself? The room stays quiet, because life isn't required for regulation. Machines regulate, systems regulate, processes regulate, and suddenly the word machine feels closer than anyone expected. The object doesn't just react to the sun, it moderates it, as if the star's energy is being filtered, managed, decided upon. The thermal shifts line up with earlier observations. The pulse, the reflectivity flashes. Everything is starting to align. Light changes. Heat changes. Not randomly, but together, as if governed by a single system. That realization hits hard, Because complexity doesn't arise easily, especially in interstellar space. For billions of years, 3I/Atlas traveled through near absolute zero. No sun, no warmth. Yet its thermal behavior suggests it was prepared for this moment. Prepared to enter a star system. Prepared to face radiation. Prepared to stay intact. Someone pulls up a comparison. A spacecraft heat shield during atmospheric entry, temperature spikes, then controlled cooling, spikes, then balance. The curves look uncomfortably similar. No one says it aloud, but everyone sees it. The sun grows stronger each day. Radiation increases. This should be the moment the object breaks down. Most comets do. They crack. They shed layers. They screen material into space. 3I/Atlas does not. Its thermal pattern stabilizes. Not hotter, not colder. Stable. As if it has found equilibrium on purpose. That's when fear quietly enters the room. Not panic. Fear is loud. This is something else. A deep, quiet unease. Because regulation without life suggests intent without biology. A different kind of existence. One that doesn't breathe but functions. One that doesn't think but operates. And suddenly, the question shifts. It's no longer, what is it made of? It becomes, why was it built this way? Thermal management is not trivial. You don't accidentally survive stellar radiation. You prepare for it. You design for it. Or you evolve under conditions we don't understand. Both options are unsettling. The data is sealed. Access limited. Not because of conspiracy, but because of caution. Extraordinary claims need extraordinary certainty. And this claim is growing heavier by the hour. As the object approaches peak solar exposure, all eyes are on the sensors. This is the test. If it fails, everything returns to normal. A strange comet, nothing more. But it doesn't fail. The temperature holds perfectly within bounds. No runaway heating, no catastrophic cooling. Just balance. A balance that feels deliberate. Late that night, a scientist watches the live thermal feed alone. The numbers scroll. Stable. Controlled. Almost calm, and a thought surfaces. Uninvited. If something can manage heat without life, without instinct, then it was made to do so. The realization doesn't scream, it whispers. And it doesn't leave. Because heat is unforgiving, you don't negotiate with physics. Unless you understand it deeply. 3I/Atlas continues inward. Silent. Unchanged. Regulating itself in a way nothing natural should. And the question hangs heavier than ever. If this object can control how it heats, how it cools, how it survives a star, then what was it built to survive? And more importantly, what was it built to do? The heat holds steady. The rules remain broken. And with every passing hour, the mystery tightens its grip. At first, it looks like chaos. Charts layered on charts. Graphs tangled with static. Lines crossing, drifting, colliding. Light, heat, pulse, reflectivity. Each dataset tells its own strange story, but none of them feel complete. So scientists do what they always do when answers hide. They combine everything, every telescope, every wavelength, every sensor, data from mountaintops, data from deserts, data from space itself. Thousands of hours of observation stacked into one picture. And at first glance, it's a mess. Too much information. Too many variables. It looks like noise. Randomness layered on randomness. The kind of chaos the universe loves. But then, someone changes the scale. They stretch the timeline. They align the datasets not by date, but by behavior. And something begins to surface. Slowly, quietly, like a shape appearing beneath rippling water. The noise starts to thin. The spikes start to line up. Light pulses match thermal shifts. Reflectivity flashes sync with brightness changes. Not perfectly, but consistently. Consistently enough to notice. That's when the room falls silent. Because randomness doesn't synchronize. Chaos doesn't coordinate. Yet here it is, a repeating structure, hidden but present. They overlay the combined data again, this time with markers. Intervals appear, regular spacing, not seconds, not minutes, longer cycles. Measured, deliberate, as if something is ticking beneath the surface. The pattern isn't simple, it's layered. A rhythm inside a rhythm, fast pulses riding on slower waves. Light responding to heat. Heat responding to orientation. Everything connected. Everything talking without sound. Someone whispers a word. Architecture. Not design, not message. Architecture. Because this doesn't look like communication. It looks like a system. A structure built to operate, whether anyone is watching or not. The data is checked again. Blind tests. Independent teams. Same result. Different methods. Same pattern. That's when denial ends. Because when patterns survive skepticism, they demand explanation. The structure isn't human. It doesn't match clocks. It doesn't match math we favor. It's not binary, not decimal. It follows intervals that feel foreign. Close to natural cycles, but not quite. Close enough to confuse. Far enough to unsettle. Someone compares it to biological rhythms. Heartbeats, breathing. But it's too precise, too consistent over time. Living systems drift. They change. This doesn't. Someone else suggests orbital mechanics. Resonance, tidal forces. But the object isn't bound to anything. No planet, no moon, nothing to lock it into rhythm. Yet the rhythm exists, unbroken, as if it carries its own rules. The realization spreads slowly. This pattern wasn't caused by our observation. It existed before we noticed, before we named it, before we pointed a single telescope its way. The pattern is intrinsic, built in. And that's the moment the question changes. It's no longer, is there a pattern? It becomes, why is there one at all? Patterns don't emerge for free. They require energy, constraints, design, or evolution under pressure. Interstellar space offers none of that. It's empty, cold, unforgiving. Nothing organizes itself there by accident. For billions of years, this object drifted through darkness. No sunlight, no warmth. Yet it preserved internal order, maintained timing, held structure. That alone is extraordinary. A simulation is run. They randomize the data, shuffle it, scramble it. The pattern disappears. Then they restore the original alignment. The pattern returns. Clearer than before. It's real, not imagined, not forced, real. The phrase hidden structure enters the discussion. A safe phrase, neutral, but everyone knows what it points toward. Hidden structure implies intention, or at least optimization. And optimization doesn't happen randomly. Someone asks a simple question. If this were natural, what would it be optimizing for? No one answers, because comets don't optimize. They decay, they lose mass, they break apart. This object doesn't. It preserves itself, balances heat, manages light, maintains rhythm, as if survival was part of its design. The pattern also doesn't change when observed. No reaction, no adjustment. It's not responding to us. It's executing something indifferent to our presence. That indifference is chilling, because if this were a message, it might care who reads it. But this feels more like a process, a function, something running, whether or not anyone understands it. One researcher leans back and exhales. If this is artificial, they say quietly. It's not trying to talk. That sentence hangs in the air, because silence with structure is worse than noise. Noise means chaos. Structure means purpose. And purpose without explanation is terrifying. The pattern repeats again. Cycle after cycle. No drift, no degradation. It doesn't age, it doesn't tire, it doesn't forget. And suddenly, time feels different. This object may be older than our species, older than our planet, carrying a pattern no one alive remembers creating, a relic or a tool or something else entirely. The data session ends without resolution. No press release, no announcement, just quiet agreement. This is no longer a single anomaly. It's a system of anomalies working together. The chaos was never chaos. It was camouflage. The pattern was always there, waiting for enough eyes, enough data, enough patience. And now that we see it, we can't unsee it. The question returns, heavier than ever. If this is a pattern, who or what designed it? Because design implies origin, and origin implies intent, and intent implies a story far larger than a passing object in our sky. 3I/Atlas continues its journey, unchanged, unbothered, carrying its hidden structure through our system, as if daring us to understand. The noise fades, the pattern remains, and with it, the uncomfortable truth. We are no longer just observing an object. We are witnessing the echo of something that knew exactly what it was doing. And whatever that something is, it hasn't finished yet. The meetings stop being public, not officially, not on paper, but the invitations grow smaller. The rooms grow quieter, doors close, because once patterns replace anomalies, science becomes careful. Inside those rooms, the screens show the same thing. Light curves, thermal cycles, repeating structure, all aligned. No longer isolated mysteries, but a single behavior wearing many masks. Someone clears their throat and says the thing no one wants to say. What if it isn't natural? No one laughs, because that question has been circling the room for days, maybe weeks. It's just never landed. Now it does. Hard. The word Comet sits on the table between them, heavy, familiar, comforting. Comets are simple, ancient, unintended. They don't plan. They don't regulate. They don't preserve structure across interstellar time. Yet 3I/Atlas does all three. So the theories begin. Quietly, reluctantly. Machine geometry. Someone pulls up models, not of rocks, but of objects built to endure. Symmetry appears, not perfect, but purposeful. Angles that favor balance, forms that distribute stress, shapes that rotate without wobble. The rotation data fits too well. Then artificial shielding, layered surfaces, directional reflectivity, materials designed to reject heat or trap it. The reflectivity flashes make sense now, not as accidents, but as features, like shutters, like panels. Someone points out something chilling. Natural erosion should roughen the surface, but the reflectivity remains sharp, defined, preserved, as if the outer layer exists to protect what's inside. The room grows quiet again. Then comes the hardest theory of all, intentional design. Not communication, not greeting. Design for function, design for survival, design for travel. No one says alien. That word is too loud, too dramatic. Instead, they say non-natural origin, a safe phrase, a careful phrase, but everyone knows what it means. If this object was designed, then someone, somewhere, understood physics better than we do, understood radiation, understood time, understood how to cross the galaxy and stay intact. That realization humbles the room, because humanity has barely left its own planet. We struggle with heat shields, with propulsion, with long-term survival in space. Yet this object has done it effortlessly, for longer than our species has existed. Someone asks the question that follows naturally. If it's artificial, what is it for? No one answers, because the possibilities are worse than ignorance. Probe, relic, debris, or something else. Something built with no concern for us at all. Theories are tested and discarded. A communication device? No decoded message. No modulation we can read. A weapon? No acceleration, no targeting. A habitat? Too small, too quiet. Everything fits and doesn't. That's the problem. This object sits just outside every category, close enough to feel familiar, far enough to remain alien. Someone suggests it might be ancient technology, not active, not aware, just running, like a machine left on long after its makers are gone. That thought chills the room, because it implies a civilization so old, its artifacts now wander alone. Passing stars, passing systems, outliving their creators. The idea isn't rejected, it's just left there, uncomfortable. The discussion turns practical. Language matters. If this isn't natural, can we still call it a comet? The answer should be simple, no. But changing classification means changing history. It means admitting something unprecedented. It means telling the world, we don't know what this is, and uncertainty at this scale is dangerous. So for now, the name stays. 3I/Atlas, a comet, on paper. But no one in that room believes it anymore. They argue over wording, over margins, over how much imagination is allowed. Because science punishes speculation, even when speculation fits the data. Someone points out the obvious. If this were built, it doesn't care that we're watching. No reaction to observation, no change in behavior. It's not hiding. It's not responding. It's simply being. That indifference feels worse than hostility, because it means we are irrelevant. Whatever built this didn't build it for us. That realization sinks deep. The meeting stretches late into the night. Coffee cups pile up, graphs blur, but the conclusion sharpens. Natural explanations are exhausted, stretched, broken. What remains are theories no one wants to name, because naming them changes everything. Outside the room, the world continues. People go to work. Cities glow, phones buzz. No one looks up, knowing something impossible is passing overhead. That contrast feels surreal. Inside these walls, humanity's place in the universe feels smaller. Not threatened, just less central. One scientist finally says it plainly. If it isn't natural, then it's proof. Proof that intelligence isn't rare. Proof that technology can outlast biology. Proof that we are not the first, and maybe not the most advanced. No one argues, because proof doesn't need belief. It just needs data. And the data is relentless. The meeting ends without consensus. No votes, no declarations, just a shared understanding. This object has crossed a line from curiosity to implication. 3I/Atlas continues its journey, unaffected by our debates, unaware of our fear. It doesn't confirm our theories. It doesn't deny them. It simply exists as a challenge to language, to classification, to identity. If this is not a comet, then our sky is no longer what we thought it was. Because if one artificial object can pass through unnoticed, how many others already have? And how many more are coming? The doors open. Scientists leave quietly. No press, no headlines, just the weight of an idea they can't unthink. That maybe, just maybe, we are no longer alone in the dark. Not because someone arrived, but because someone passed through and didn't bother to say hello. At first, it's just a rumor, a screenshot shared in a private group, a cropped graph with no context, a sentence taken out of a draft report. Most people scroll past it. The internet is full of mysteries. Most of them fade by morning. This one doesn't, because more pieces begin to appear. A thermal chart here, a brightness curve there, different sources telling the same strange story. And slowly, quietly, the leaks spread. Not as headlines, not as breaking news, as whispers. A science blogger posts a thread. Careful words. Lots of disclaimers. I might be wrong, they write, but something doesn't add up. The post gets shared, then shared again. Then someone notices a pattern. The same terms keep appearing. Pulse, reflectivity, anomaly, words that don't belong together. Soon, mainstream outlets catch the scent. They don't accuse. They don't speculate wildly. They just ask questions. And questions are powerful. What is 3I/Atlas? Why are some datasets restricted? Why won't anyone explain the thermal irregularities? Scientists respond the way they always do, with caution, with half answers, with phrases like ongoing analysis and no confirmed conclusions. The public hears something else, uncertainty, and uncertainty changes how people feel. At first, curiosity grows. People look up, literally. They search for sky maps. They download stargazing apps. A faint object, passing silently overhead. It feels thrilling, like witnessing history. But then the tone shifts. Someone connects the dots. Interstellar. Unusual behavior. Restricted meetings. Old science fiction clips resurface. Not because people believe them, but because imagination fills gaps faster than facts. Late-night talk shows joke about it. Memes appear. Friendly visitor? Alien Wi-Fi? People laugh. Because laughter keeps fear at bay. But beneath the jokes, something darker settles in. Because this isn't an asteroid. It isn't a threat you can see coming. It's a question. And questions make people uneasy, especially when experts don't have answers. A teacher pauses mid-lesson when a student asks about it. Is it true, they ask. Is it artificial? The teacher hesitates. That hesitation says more than any answer. Forums fill with arguments. Some dismiss it completely. Just another rock. Media hype. Others feel something deeper, a sense of being watched, even though no one is watching us. That paradox is unsettling, because fear doesn't always come from danger. Sometimes it comes from irrelevance. People realize something important. This object didn't come here for us. It didn't slow down. It didn't announce itself. It didn't care. And that indifference is hard to accept. For centuries, humanity has believed it mattered, that the universe noticed us. That discovery meant importance. But what if discovery means the opposite? What if we are just on the way? Late one night, a news anchor stares into the camera. Careful tone, measured voice. They say, "Scientists assure us there is no threat." The word threat lingers. No one asked that yet, but now they are. People lie awake longer, not scared, just thoughtful, looking at the ceiling, at the stars outside their windows, realizing how quiet space really is. Astronomers receive emails from strangers, some hopeful, some angry. Tell us the truth. Why are you hiding it? Do they know we're here? They don't know how to answer. Because the truth is smaller and bigger than anyone expects. The truth is, they don't know anything more than before. They just know less about themselves. Because observation doesn't just change objects, it changes observers. Once you see something that doesn't fit your world has to stretch or crack. People begin to project. Religions reinterpret texts. Philosophers resurface old questions. What is intelligence? What is purpose? What does it mean to exist if something older and quieter can pass us by? The fear isn't invasion. It's comparison. We compare our noise to its silence, our chaos to its control, our urgency to its patience. And suddenly, we feel young, very young. A scientist gives an interview off the record. They don't speculate. They just say something honest. This object doesn't change what's out there. It changes how we see ourselves. That line spreads faster than any data, because people feel it. For the first time, discovery isn't empowering, it's humbling. There are no alarms, no sirens. Life continues. But something subtle has shifted. People realize the universe isn't waiting for us. It doesn't revolve around our questions. It doesn't need our understanding. 3I/Atlas keeps moving, unchanged, unaware of the conversations it sparked, unmoved by the fear or wonder or awe. And that's the awakening. Not the fear of contact, but the understanding of scale, of age, of insignificance, and possibility existing together. Some people find peace in that, others don't. Some feel smaller. Others feel freer, because if we are not central, we are not alone in responsibility. The sky feels different now. Not hostile, just honest. As the object continues toward the edge of observation, the noise online grows, then slowly fades. People move on. Bills still need paying. Mornings still come. But something lingers, a quiet awareness that one day, without warning, something ancient passed through our home, and we noticed it, not because it spoke, but because it didn't. And that silence changed us. The awakening doesn't come with answers. It comes with a feeling that the universe is larger, older, and less concerned with us than we ever imagined. And once that feeling arrives, you don't forget it. You just learn to live with it, looking up a little longer than before, wondering what else might be passing by right now. At some point, everyone expects it. A spike, a burst, a moment where the mystery breaks open. A message, because that's how stories usually go. We discover something strange, and then it speaks. But 3I/Atlas never does. Weeks pass, sensors stay locked on. Algorithms run non-stop. Filters grow sharper. Radio telescopes listen. Optical arrays watch. Signal hunters search every gap in the noise. Nothing. No encoded burst. No repeating transmission. No reply. Just silence. Not the empty kind. The other kind. The kind that feels intentional. Because this object is not quiet by accident. It pulses in light. It regulates heat. It follows pattern. It does many things. It simply chooses not to speak. And that choice begins to feel heavier than any signal ever could. Scientists try everything. They search for modulation in the pulse, for hidden layers in the light curve, for frequency shifts too subtle to notice at first glance. They stretch the data, compress it, translate it. They listen for whispers inside the numbers. Still nothing. The object is consistent and restrained, as if it's following a rule. Do not transmit. Do not announce. Do not engage. That restraint is unsettling, because silence, when paired with complexity, stops being absence and starts becoming behavior. Someone points out the obvious. If it wanted to talk, it could. The object reflects light with precision, manages energy with control. If communication were the goal, we would see something, anything. But there's nothing, no greeting, no warning, no curiosity, just passage. Like a traveler who doesn't look out the window, the idea begins to take shape. What if the silence is the signal? Not a message, but a statement, a declaration of intent, or lack of it. In nature, silence is common. Rocks don't speak. Stars don't whisper, but they also don't regulate themselves. They don't preserve structure across interstellar time. They don't behave with restraint. This does. And restraint suggests awareness of consequence. Because if you know others might hear you, choosing silence matters. The search for meaning turns inward. Maybe it's not meant for us. Maybe it was never meant to be heard at all. Maybe this object is doing something else entirely. Executing a task, following a route, completing a cycle, like a clock that doesn't care who checks the time. That thought reframes everything. If 3I/Atlas is a system, not a messenger, then silence makes sense. Machines don't speak unless designed to. They operate, they endure. They finish what they were built to do. And the more scientists look, the clearer it becomes. This object is not reacting to us, not to observation, not to attention, not to curiosity. It doesn't hide. It doesn't change. It doesn't acknowledge. That indifference feels colder than hostility. Because hostility admits awareness, silence suggests something worse: irrelevance. Late-night discussions turn philosophical. One researcher says it quietly. If this is intelligence, it's not our kind. Human intelligence wants to be known, to be seen, to leave a mark. This doesn't. It passes through a star system full of life and doesn't blink. No curiosity, no hesitation, just trajectory. That realization shifts the fear. People stop asking, what does it want? They start asking, why doesn't it care? Because care implies priority, and priority implies value. And suddenly, humanity is forced to consider something uncomfortable. What if we are not valuable to the wider universe? Not special. Not central, just present. The silence becomes louder. Journalists keep asking, have you decoded anything yet? Scientists keep answering, no. The word becomes routine, almost boring. But behind it sits a growing tension. Because if silence continues, then it must be accepted. And acceptance changes things. It means this object exists without us, before us, after us. And that means intelligence, or technology, or something else entirely, does not need to announce itself to matter. One analyst compares it to deep-sea probes, machines sent into darkness, recording, enduring, never speaking unless required. If that's the case, then what is this object observing? The question is never answered, because there's no evidence it observes at all. No scanning beams, no data bursts, just movement. And movement itself can be the function. Maybe it's mapping gravity, testing stars, sampling radiation, or maybe it's just passing through. A piece of something larger, a fragment of a system we can't see. That possibility lingers, because if one object can cross our system silently, so could others. We might never know. That thought humbles the search, because listening only matters if something wants to be heard. And maybe the universe doesn't. Maybe it doesn't explain itself. Maybe silence is not a failure of communication, but the default state of intelligence, older than language. As days pass, the listening continues. Quiet rooms, soft hum of machines. The object drifts further. Still no signal, still no deviation, still no acknowledgement. And slowly, the urgency fades. Not because the mystery is solved, but because it refuses to perform. It won't give us a moment. It won't give us closure. It won't give us meaning. And that, strangely, feels honest. Because meaning is something humans impose. The universe does not owe us answers. 3I/Atlas proves that. It shows us a different model. Existence without explanation. Function without audience. A presence that does not announce itself. Because it does not need to. As the object approaches the limits of optimal detection, the silence remains unbroken. No last message, no farewell, just steady motion. And the final question settles in, not with fear, but with clarity. If silence can be chosen, if restraint can be intentional, then maybe the loudest statement ever made is one that says nothing at all. The silence of 3I/Atlas does not invite us. It does not warn us. It does not comfort us. It simply reminds us that intelligence does not always speak. And when it doesn't, it may be because it has nothing to prove, or because we were never meant to listen in the first place. The signal never comes, but the silence stays. And somehow that changes everything. There is a moment, quiet and easy to miss, when knowing begins to slip away. Not suddenly. Not dramatically, just gradually. 3I/Atlas keeps moving. Day by day, it drifts farther from the sun, farther from Earth, farther from the reach of our best instruments. At first, nothing feels different. The data still arrives, graphs still update, numbers still scroll, but the resolution softens just a little. The signal-to-noise ratio drops. The margins grow wider. Uncertainty creeps in. And scientists feel it immediately, because science lives in precision, and precision is fading. Telescopes strain to hold focus. What once looked sharp now looks blurred. Brightness readings flatten. Thermal curves smooth out, not because the object has changed, but because distance is winning. This was always going to happen. Everyone knew it. But knowing something is coming doesn't make it easier when it arrives. 3I/Atlas has passed perihelion. The sun no longer lights it the same way. Angles shift. Reflections weaken. Those strange flashes still there, but harder to separate from noise. The pulse that once felt undeniable now feels faint. Not gone, just quieter. And quiet at this distance is dangerous, because quiet can mean absence or limitation. No one is sure which. Scientists request more time, longer exposures, more resources. But the sky doesn't wait. Earth keeps turning. Schedules conflict. Other missions demand attention. The universe does not pause for curiosity. The data becomes thinner, a little less reliable each night. And with it, certainty begins to dissolve. Models that once aligned perfectly now drift. Error bars expand. Simulations disagree again, not because the object changed, but because our view did. That distinction matters. And it hurts. Because there's a growing sense that this was the window, the moment, the one chance. Interstellar objects do not linger. They pass through, and they leave. And once they're gone, they take their secrets with them. Someone pulls up the earliest data again. The clean curves, the strong pulses, the undeniable patterns. They feel closer now, almost nostalgic, as if those moments belonged to a different era, a time when answers still felt possible. Now, everything feels just out of reach. A senior researcher says it quietly. We're losing it. Not emotionally, scientifically. The signal is slipping below detection thresholds. Soon, it will blend into background stars. Just another faint point of light among billions. The realization settles heavy because no probe was sent, no intercept attempted. There wasn't time. There never is. Humanity watched from afar and hoped observation would be enough. Now, doubt creeps in. Was it enough? Did we ask the right questions? Did we focus on the wrong details and miss the essential ones? Some argue that nothing more could have been done. Technology has limits. Physics has limits. Distance always wins. Others feel something sharper. Regret. Because this object challenged everything we thought we knew, and we could only watch it leave. The data meetings grow shorter. There's less to discuss, not because the mystery is solved, but because it's escaping. The object's behavior becomes harder to distinguish. Patterns blur, noise reclaims the signal, and slowly the conversation changes from "what is it?" to "what was it?" That shift feels final, as if the story is already ending, even though the object is still out there. Someone asks the question that hurts the most. Did we miss our only chance? No one answers, because maybe there was never a chance to begin with. Maybe understanding was never the point. Maybe this object was never meant to be known. That thought reframes everything. Because not all mysteries are invitations. Some are just passing through. Late one night, a scientist watches the live feed again. The dot is barely visible now. Faint, unremarkable. If they hadn't known its history, they would have ignored it. That realization stings. Because context is everything. Without context, this object is nothing special. With context, it may be the most important thing we've ever seen. And context is slipping away with distance. The public has mostly moved on. New stories replace old ones. Attention shifts. That's how humans work. But in research rooms, the feeling lingers. A sense of incompleteness, of unfinished thought. Because discovery without understanding feels hollow. It raises more questions than it answers. And those questions now have no place to go. The final, high-quality datasets are archived, labeled, stored 3I/ATLAS. Close approach phase, past tense. From here on, everything will be inference, speculation, memory, and memory is fragile. Years from now, someone will reopen the files, run new algorithms. Look with fresh eyes. Maybe they'll see something we missed. Or maybe they'll only see how close we came. The object continues outward, back into interstellar darkness, back into anonymity. Whatever it is, whatever it was built for, whatever history it carries, it's taking that story with it. The sun fades behind it. Earth becomes just another star, indistinguishable from the rest. And that fact is sobering, because from its perspective, we were never special. Just a system it passed through, a momentary light in a long journey. As 3I/Atlas crosses the boundary where certainty ends, a quiet truth settles in. Knowledge has a horizon, and we just crossed it. Beyond this point, there are no more measurements that can save us, only interpretation, only reflection, only questions that echo without answers. Did we miss our only chance? Or was the lesson never about understanding the object, but understanding ourselves, our limits, our scale, our place? The data fades, the object recedes, and humanity is left standing at the edge of knowing, watching something impossible disappear into the dark, wondering if the universe offered us a glimpse, or simply reminded us that not everything is meant to be understood before it's gone. It leaves the way it arrived, quietly. No flash, no farewell, no final clue hidden in the data. 3I/Atlas drifts beyond the inner system, past the orbits that matter to us, past the point where sunlight can reveal its secrets. And then it's gone, not vanished, just unreachable. The object doesn't break apart, doesn't change course, doesn't react. It exits exactly as it entered, unchanged, unresolved, unexplained. The last clear image is archived. A faint shape against black. No drama. Just distance winning again. And for a moment, there is silence. Not the silence of mystery this time, but the silence that follows acceptance. Because the chase is over. Whatever 3I/Atlas was, it no longer belongs to us. The research teams disband slowly, not officially, but naturally. People return to other projects, other questions, Mars missions, exoplanets, dark matter. The universe is full of problems that can be worked on. This one can't. The files remain, carefully labeled, carefully stored. Thousands of hours of observation. Light curves that bent the wrong way. Thermal patterns that shouldn't exist. A pulse with no sender. A structure hidden beneath noise. All of it real, all of it unanswered. Years from now, students will study this data. They'll run new models, better algorithms, stronger machines, and maybe they'll see something clearer. Or maybe they'll only see what we saw. A boundary, a limit, a reminder. Because the strangest part isn't that we didn't solve it. It's that the universe didn't care whether we did. 3I/Atlas didn't test us, didn't warn us, didn't challenge us directly. It simply existed on its own terms. And that fact lingers longer than any conclusion. The public memory fades, as it always does. A few documentaries, a few books, then new mysteries arrive, but something subtle remains. A quiet shift in perception. Astronomers don't say it out loud, but they feel it. When they look at new data, they hesitate longer. They trust assumptions less, because now they know. Something passed through our system that didn't fit. And fitting things into boxes is what humans do best. Until something refuses, philosophers pick up where science paused. They ask questions science can't measure. What counts as intelligence if it never speaks? What counts as life if it regulates but doesn't grow? What counts as evidence when silence is consistent? Religions don't collapse, but they soften, expand, because a universe with quiet, ancient travelers feels different than one made only for us. Children look at the stars a little differently now, not with fear, with curiosity and humility. because the idea has settled in. We are not the first to pass through this galaxy. We may not be the most advanced. We may not even be particularly interesting on a cosmic scale. And somehow, that's okay, because meaning doesn't vanish when importance does. It changes. The truth that doesn't leave is not about aliens. It's about perspective. For centuries, discovery meant dominance. We charted oceans, mapped continents, named stars. To name something was to own it. 3IATLAS resisted that instinct. We named it, but we didn't own it. We observed it, but we didn't understand it. We followed it, but it didn't slow down. And that changes the relationship, because the universe is no longer a puzzle waiting to be solved. It's a process we are part of, but not in control of. Late one night, an astronomer stands outside an observatory. The sky is clear. The stars are sharp. They know exactly where 3I/Atlas would be if their eyes were strong enough. Somewhere out there. Still moving, still silent, still structured. And a thought arrives. Simple and heavy. If something that advanced, that controlled, that old, can pass through without caring, then intelligence is not rare. It's just quiet. That realization reshapes everything. It means the universe may be full of stories that never introduce themselves, full of machines or relics or processes that don't need witnesses, full of meaning that isn't centered on us. And once you accept that, you stop waiting for contact. You stop expecting answers. You start listening differently. Not for messages, but for patterns. Not for voices, but for behavior. The truth that doesn't leave is the shift itself. We no longer look at comets the same way, or anomalies, or silence. Silence is no longer empty. It's loaded, intentional. Possibility disguised as nothing. 3I/Atlas didn't change direction, but it changed us. It taught us that discovery doesn't always end in knowledge. Sometimes it ends in humility. Sometimes the most honest outcome is not knowing and living with that. The object is gone now, beyond reach, beyond light, but the questions remain. Was this just a passing unknown, a rare accident drifting through the dark? Or was it evidence of something larger, older, quietly active across the galaxy? A system of travelers, unseen, uninterested, passing through star systems like ours. All the time, we don't know. And maybe we were never meant to. The universe doesn't owe us closure. It doesn't explain itself. It simply continues. And now, so do we. Looking up, not for answers, but with a new understanding. That we are part of a much bigger story. One that doesn't pause, doesn't explain, and doesn't announce itself. As it moves silently through the stars. Just like 3I/Atlas did. Unchanged, unresolved, but unforgettable, because some truths don't arrive with answers, they arrive with a shift. And once that shift happens, you never see the universe the same way again.